Hello. For my three chapters, I had chapters 1 through 3. So we'll start with chapter 1, which is sets, using attributes to make collections. Um, the first big idea of that chapter is that attributes can be used to sort collections into sets. Um, this means that you can use the attribute of something, such as just color, shape, or size, and sort it into different sets. Sets are any collection of items that is grouped together in a way that is meaningful. So a real life example of this big idea is a big or small activity. So you would use different size counting bears. Um, what the children do is pick a random bear out of the bag and then sort it either into the big pile or the small pile, depending on the bear's size. This is a hands-on activity that will teach them about sorting different sizes into sets. The next big idea for the chapter 1 is the same collection can be sorted in different ways. So for young children, this big idea can be hard to understand since it requires thinking about the many different characteristics of single items. When children begin to understand this idea, they have learned something important about same and different that will help them become abstract thinkers and problem solvers in math later on. A real life example that can be used in the classroom about this big idea is taking large beads that are different colors and different shapes. First, have the children find all of one shape of the bead. So for example, find all the stars and sort it into their piles. Then have the children look at that pile of stars that they sorted out, which can be all different colors, and then have them sort from the star pile to smaller piles of the stars matching colors. And the last big idea for chapter 1 is that sets can be compared and ordered. So as soon as a collection is broken up into sets or groups, children show a strong instinct to compare. Sometimes the comparison is about which set is better or more preferred. It is important for the teacher of young children to know that ideas of more, less, and equal become more complicated when the items in the sets are of very different sizes or shapes. A real life example of this big idea that teachers can use in the classroom is by using different size rocks to compare sets. So for example, have a pile with 2 big rocks and a pile with 5 tiny rocks. Then ask the question, which pile has more rocks? Some children might want to say that the big rock pile has more because the rocks are bigger. Then the teacher can jump in and show the group that just because it's bigger and taller doesn't mean there's more of that rock, because in this case, there is more of the smaller rock. This moves us on to chapter 2, which is number sense, developing a meaningful sense of quantity. So the big ideas for this chapter is that numbers are used in many ways, some more mathematical than others. So a single numeral can mean different things in different situations. Numbers are used just about everywhere in life, and they don't always have to be used in their basic numerical definition. So an example of that is our textbook states that if a baseball player's jersey has a number 5 on it, that doesn't necessarily mean that he's the 5th at bat player. Ordinal numbers are the order that they go in, so it's first, second, third. And cardinal numbers is how many or how much. So an activity that the teacher can use in the classroom for this big idea is to teach, it would be putting a number 1, 2, and 3 on the floor, like the physical number. Tell a child to go stand on the number 1. This would be teaching cardinal, and then tell another child to stand on the 3rd place on the row, which is teaching ordinal. That's the number 3, but it's the 3rd place in line. So it's the same thing. The second big idea is that quantity is an attribute of a set of objects, and we use numbers to name specific quantities. So this means that in order to understand the numerosity of a set, you have to see past the qualities of the things themselves and see only quantity. If there are 3 apples lined up and the teacher asks, how many apples are there? And the student says 3, then they understand the question of the quantity of objects, but not what the objects look like. A real-life example of this concept would be to line 3 different size and color blocks up on the floor. First, the teacher would ask, what color are the blocks? Then, which block is smaller, which one is bigger? And then asking how many blocks are in the row. This can help the children know that a set of objects can have many different attributes. The last big idea for this chapter is the quantity of a small collection can be intuitively perceived without counting. So this means all children are born with an innate ability to perceive the difference between 1 and 2 objects. With support and experience, they can quickly perceive and name how many for collections of 3, 4, 5, and so on. This mathematical ability is called subitizing. And an example of this concept would be having the children study a dice. After enough exposure with a die, they would be able to memorize the pattern that the dots are in with how many it is. So, for example, on a die, the number 6, there's 3 lined up, and 3 dots lined up, and then 3 dots lined up next to it. They'll be able to memorize the pattern that the dots are in with how many it is, so that's 6. Then the teachers could use the objects in the classroom to set them up in the same number patterns that are on the die. So they could take 6 blocks and put them in the same pattern that's on the die. So it would be 1, 2, 3, and then next to it 1, 2, 3. The kids could then look at that and say, oh, it's 6, without even having to count it, because they memorized the pattern that's the number 6 is on the die. So they can use that to memorize how much of an object is. It becomes harder when a number of objects are put into different patterns that are on a die. So if it was like 6 lined up straight, or 3 on top, 3 on bottom, it could be harder for them to, differentiate how many of the object there is. This moves us into chapter 3, which is counting. It's more than 1, 2, 3. Counting can be used to find out how many are in a collection. So this is pretty self-explanatory. Children can use one-to-one count to count a number of objects in a collection and be able to determine how many of the object there is. There is a counting game that I have played with my students in the past, where I grab a random number of objects, like counting bears or something small, and I put it on a tray. And I have a different number every time I play it. I set them up in different patterns every time I do it too. So sometimes if it's 6 bears, some it'll be 3 on top, 3 on the bottom, or 3 lined up and beside each other, or just scattered on the tray. This has the children come up and either be able to be like 1, 2, 3, 4, or if they have more experience with it, they can just look at it and be like, there's 6 there. So the more you practice that, the more children will be able to pick out the number without having to sit there and count it individually. And then the last big idea of this chapter is counting has rules that apply to any collection. So because the order of number names is conventional, memorizing the sequence you have to start with that in order to use the stable order rule in counting. However, understanding the stable order rule is more than just the rule resuscitation of a number sequence, memorizing 1, 2, 3, 4, 5. Mathematical structures and patterns are embedded in the process of the rules applications. So no matter what word or symbol we use to designate a quantity, each number is always 1 more than the number before it and 1 less than the number after it. So a good way to practice this would be to have a die and some goldfish. First, you would have the child roll the die and determine what number they landed on, and then have them go up to the bowl and pick out how many goldfish they got out of the bowl. So if they landed on 6, they would pick out 6 goldfish out of the bowl. Then they would be able to determine how many of something they can pick out just by what they landed on the dice. And that is what I have. Thank you.